So we already talked about different types of chemical reactions. We said we have three types. We have precipitation reaction, we have acid-base reaction, and we have oxidation-reduction reactions. We already talked about precipitation reaction in 3 videos so far, and I want to talk a little bit about acid-base reaction in the first part of the video. So what is acid-base reaction? In an acid-base reaction, and sometimes called neutralization reaction, an acid reacts with a base and the two neutralize each other, producing water, or in some cases a weak electrolyte. It can be a weak acid or it can be a weak base. So we have different definitions of acids and bases. So one of the definitions is based on Arrhenius' concept, or Arrhenius' concept of acid and bases. So let's see what are the definitions of acid and bases based on Arrhenius' concept. So an acid is a substance that produces H+ or proton ions when dissolved in water. A base is a substance that produces OH ions or hydroxide ions. This H+ ion is called proton because, as you know, hydrogen has 1 electron and 1 proton, and if it loses 1 electron, it means that H+, it means that it has only 1 proton in its atom. So it means that we have only 1 proton, and that's why it's called proton ions. So an acid is a substance that produces proton ions, and a base is a substance that produces OH ions or hydroxide ions. So according to the Arrhenius definition, HCl, which is a strong acid, is an acid because it produces proton ions in solution. So as you see here, we have HCl aqueous solution, and when we dissolve it, it's going to produce proton and chloride. So since one of the product is proton, we call it HCl and acid. And proton ion is a bare proton. In solution, bare protons normally associate with water molecules to form hydronium ions. So when we have water, so basically we are talking about aqueous solution. So in aqueous solution we have water, so proton plus water is going to give us H3O+, or this one is called hydronium ions. So both of them basically have the same meaning, hydronium ion and proton. Basically they have the same meaning. So for example, HCl plus water is going to give us hydronium ion plus chloride. And if we compare it with the previous equation we had HCl, it's going to dissociate into H and Cl. And here we have HCl plus water, which is also correct. We have hydronium plus chloride. So we can use either hydronium ions or proton. Here. So some acids are polytropic. It means that they have more than reactive proton in their molecule. So some acids called polyprotic acids, they contain more than 1 ionizable proton, and they can release more than 1 proton when they react with something else or when they dissolve in water. So they release these protons sequentially. So for example, sulfuric acid is a polytropic acid, or it's sometimes called diprotic acid because it has only 2 protons. So as you see here, sulfuric acid is a very strong acid. It releases 1 proton, and we have HSO4 minus. Also HSO4 minus, we have 1 more ion. So next step, this one acid is going to be weaker. So we have proton plus SO4 2 minus. So we have proton plus sulfate. So it releases 2 proton in 2 steps. On the other hand, Arrhenius concept of bases, we have, for example, sodium hydroxide. Sodium hydroxide is a base because it produces hydroxide ion in solution. So we have NaOH, it produces sodium, which is a cation, and hydroxide ion, which is an anion. Let's have some common acids and bases. So on the left hand side we have name of acid and the formula, and the right hand side we have name of some bases and their formula. We have hydrochloric acid, which is HCl, hydrobromic acid, which is HBr, hydroiodic acid, which is HI, nitric acid, HNO3, sulfuric acid, H2SO4, perchloric acid, HClO4, acetic acid, which is a weak acid, HC2H3O2, and hydrofluoric acid, which is this one. This one is also a weak acid, HF. On the other hand, we have sodium hydroxide, NaOH, lithium hydroxide, LiOH, potassium hydroxide, KOH, calcium hydroxide, CaOH2, barium hydroxide, BaOH2, and ammonia, which is a very weak acid, weak base. So we have NH3 here. I'm gonna talk about it. We have a star here because based on the definition of Arrhenius definition, we said base is the one that when dissolved in water it produces hydroxide ion. But this one, ammonia, it doesn't have it. But this base is gonna be categorized under base family based on another definition of bases. So that's one of the disadvantage of Arrhenius concept of acids and bases. So in other videos I'm going to talk about other definitions of acids and bases.